Hello everyone, welcome to SNDF. Today we'll be solving our second questions of lead code array series, which is to sum. So let's get started. The problem is simple. Given an array of integers num and an integer target, you need to return the indices of the two numbers in the array that add up to the target. Here is an important point to remember that you may not use the same element twice. Let me show you a quick example first. So you have a nums array and a target variable of 9, and the output will be 0 and 1 as number 2 and 7 add up to number 9. So you have to return back 0 and 1 at their indexes. So now the basic approach would be to and now the basic approach would be to use the brute force approach. So here first we can try adding each element in the array with every other element and check if their sum matches the target. This works, but it takes big of n squared time complexity, which means it gets slow when you have a large array. Here is what that brute force solution would look like in Java. You can go to the code, I'll give you the Notion link. But now let's move to the optimal solution where we use a hash map to reduce the complexity to big O of n. The idea here is to use the hash map to store the elements of the array as we iterate over them. For each element, we calculate what's called the complement, that is the number we need to find to get the target. If the complement already exists in the hash map, we have found the solution. Here's an algorithm walkthrough that might help you. That we have to first create the hash map, then have to loop through the array, then if for each element in nums of I, we have to calculate the complement of that. Then check if the complement exists in the hash map. If the complement is found, we have to return the indices of the complement and then the current number. You will be having this code in your Notion link, don't worry about that. So let's now walk through the code details. First, we have to create the hash map to store the integer number as the key and its index as the value. This will allow us to look up a number in the constant time. We then start a loop that goes through each element in the nums array. For each element nums I, we calculate its complement, which is the number that when added to nums I gives us the target. Next, we check if this complement is already in the hash map. If it is, that means we have already seen the number and we need to pair with nums I. If we haven't seen the complement yet, we add the current number nums I and its index I to the hash map for the future checks. Once we find the pair, we return the indices in a new array. So let's take an example. So for example, we have this nums 2, 7, 11, 5. In the first iteration, we store 2 in the hash map and move on. In the second iteration, we find 9 minus 7 is equals to 2, and we already have 2 in the hash map. So we return the indices 0 and 1. It seems a bit easy here. So the beauty of this approach is that it only takes big O of n time because we only loop through the array once. Also, our space complexity is big O of 1 because we are storing each element in the hash map. And that's it.